right, guys, we're going to go on and get started. With this here. Now, before we start the lesson, are there any questions over the homework? Questions over the homework assignments? Might need a note sheet. No. Yeah, we finished the note sheet, that one in a day. Yeah.
Good morning, Concord High School. Please stand for the Pledge of Allegiance. I already did that.
So, 6.5, properties of logarithms. Now, out of the 3 properties of logarithms, we have talked about one of these yesterday. And the one that we talked about was the power property. Because when we looked at this here, let's look up here, power property, log base b of m to the n is equal to n times log base b of m. And we saw that with our properties yesterday, where we were talking about log base 7 of 7 to the 2x. This is one of the ones we looked at possibly, but I'm just throwing one up here. And according to this property, we can take this 2x power and move it to the front. Like I said, we have 2x times log base 7 of 7.
Wouldn't it be just 2x 1?
It'd be 2x times 1, because whenever the base and the number inside are the same, it's just 1, and our 2x times 1 gives us 2x. So that's our power property. Now, the other 2 properties we have are the product property. Our product property states if we have 2 or more things multiplied together inside the logarithm, we can rewrite it as an addition of logs. So if we have log base b of m times n, it's the same as log base b of m times log base b of n. We can rewrite it as a sum. Product inside becomes a sum of logs. Our quotient property, if we have a division of 2 or more things inside the log, we have something being divided inside the log, it becomes a subtraction. Division inside becomes subtraction outside. Subtraction of logs. Now this normally comes up or is asked if we had log base b of m minus n. Is this the same as log base b of m divided by log base b of n? And that is not the case. These are not the same. Subtraction inside does not equal division outside. It's just subtraction. Questions on these so far? Questions on anything we've looked at so far? Because we haven't actually looked at anything yet. We've just looked at these properties. Now, when we expand a log, the order of the properties that we use, it's going to be our, because expanding back out is normally going to be division, our quotient property, then our product, and the last one's our power. We do division, product, power. Our quotient, product, power. Quotient property first. Division, quotient, division property first. Product, our multiplication property second. And our power property is always last. Okay. That helps me for later. Questions on this order? Now, nice enough when we condense, because we're going to expand, we're going to break it all the way apart, and we're going to condense it back. Condensing the steps are a little bit nicer, but we'll get there in a minute. Questions on this so far? So the first one we're doing is division, our quotient property. And when we look at this here, ln of 5x, 5 times x to the 7th divided by y. Division says if I have a log with the same base of 2 things being divided, it is the same as log base b of m, the numerator, minus log base b of n, the denominator, the top minus the bottom. So here, if we want to expand this with our division property, because we do have division inside the logarithm, we're going to have natural log of the numerator, the top, which is 5x to the 7th, minus the natural log of the denominator, the bottom, which is ln of y. Top goes in the first one, bottom goes in the second. Questions on this so far? Questions on our division property? We good with this so far? Now I do want to point this out. It's not super key at this point, but anything in the bottom of the fraction is going to have a minus in front. Anything that's going to be in the bottom of that fraction or is going to stay there should have a minus in front. So if we have 3 things in the bottom, we should expect to have 3 logs with a minus in front. So we good with our division property, our quotient property? Okay. The next one is product. Anytime we have 2 or more things multiplied together, it is the same as addition. So what this is saying is that log base b of m times n is equal to log base b of m plus log base b of n. And the only one out of these 2 that actually has a product is the first one, the natural log of 5 times x to the 7th. 5 times x to the 7th. Well, our 2 terms are what? 5 and x to the 7th. So our first one would be ln of 5 plus ln of x to the 7th minus ln of y. Now, if the other one had multiple things in there instead of just y, if it was x times y, we would have ln of x plus ln of y. We would need parentheses because of that negative, but we would do the same thing for it. Questions on product? Is there anything else where we have 2 different things being multiplied together? I was about to say terms, but if they're together being multiplied, it's a single term. Well, no, the only one we have is x to the 7th, because that's really x being multiplied by itself 7 times, but it's going to go under power. ln of 5 is simplified plus our power property, log base b of m to the n is equal to n times log base b of m. We can take that power and move it to the front, which tells us that we have what? Plus 7 times the natural log of x minus the natural log of y. I have to write that other part in black to signify our main thing that's changing. That's it. This comes in more helpful for solving, because there's sometimes if we're looking at 2 logarithmic expressions at the same time, it's sometimes helpful to put them together or rearrange them. But really outside of that, there's not, most of the practical applications of logarithms and their properties, there is an algorithm set up to do it. And for the average person, not a lot. But the the logical thinking and putting it together, taking it apart, helps more than the actual concept here. Does that make sense? And that's most of Algebra 2 as a whole. It will come back up in college algebra if you take it. It'll come back up, but that's about it. So we're just taking it all the way apart. Now that can sometimes be helpful, especially if one of these expressions does simplify. Because if, not so much with natural logs, but if one of them had been e, because we had 7e in it, then the natural log, I can split the 7 and the e apart, the natural log of e would reduce. We have one less thing to take care of. All right, we have this next one here. We want to expand 3x to the 5th over y. Well, again, division is first, product is second, power is third. So yes, we have a division here. So to start off, we'll have our numerator minus our denominator. Let's focus in here. Head up, Owen. Thank you. So when we do this here, it's the numerator, natural log of the numerator minus the natural log of the denominator. Now, even though all of our rules are set up with LOG, natural log works the exact same way. It's just the base is understood to be E. Questions on how we did this here? Well, then we would do product, yes. So the first one would be indeed ln of 3 plus ln of x to the 5th minus ln of y. And that's all the multiplication. I mean, x to the 5th is technically product, but I don't think we want to rewrite that as ln of x plus ln of x plus ln of x plus ln of x. I think that was 4 plus ln of x. We rewrite it 5 times. But since they're all the same natural log, they would be like terms and they would combine to give us plus what? 5 ln of x. We have ln of 3 plus 5 ln of x minus ln of y. That's it. Questions on this here? So those are each of the steps, but our final answer is the bottom part. Now, if you notice in all the general expressions, we have log of b, log of b. It's just saying that the base does not change when we split it up. Yes. Put this down. And I'll write it over here in purple, expand. The order for expanding is quotient, our division, product, well, power, exponent. It's not so much that it changes. The reason I say I use a little bit different for condensing is it's kind of a reference I've made already. Because I pointed out that if something's in the bottom of the fraction, it's got to have the minus in front, yes? So if we're writing the terms out, well, there's nothing that says that I have to have it in any specific order, because we could have ln of something minus ln whatever plus ln. We have our term minus ln and keep going on. And I'm not so much worried about what's inside the logarithms, but it's signs. Because any of the signs that are on bottom for the sign that's supposed to go on bottom is going to have this minus or negative in front. So to get there, and I've tried to work through it, it's like, okay, well, if that's the case, any of them with negatives, we've got to put all together. Any of the ones with positives, we've got to put together. Then we have to factor the negative out. And it's a lot of steps if we try to stick to this order. And condensing, I'm not going to fill it in yet, but condensing has 2. because I've worked through or kind of thought about different ways to do this. But when we condense it, we only have two steps, or two main steps. Expanding, we have three. And that's partly because of quotient. Makes things a little weird when we try to put it back together. Because if it's not ordered so that all the negatives are together and all the positive ones are at the start, kind of as you notice the last ones, we had all the positive logarithms first and then the negatives, our bottom was at the end, then we have to do a little bit more. But we will get to that here. Now, luckily for us, most of the ones we'll do, there's only one minus. And that's all great and good, and we could stick to a set method that works with it if we have one negative. I don't like that. I want you to have a way to do it that works every time, no matter the setup. Does that make sense? Now, we're going to look at number 5. We want to expand log base 6 of 3x to the 4th. So we always start off with quotient, our division. Is there division? No, so we have to do step 1. No, it's not there, so we move on to step 2, which is our product. Since we have two things being multiplied, it is the same as log base 6 of our first spot, our 3, plus then we're going to do product. So, product first, which we split it apart. We finished that. Now we're going to do power. Power states that we take this 4th power with x and move it to the front. So we have log base 6 of 3 plus 4 times log base 6 of x. Questions on this here? Luckily for us, log base 6 of 3 does not simplify in any nice way. It does, but it's a decimal, so we're going to leave it alone. Does that make sense? Now, if it had been log base 6 of 6, well, we know what that is. That 1. If it's nice, go and simplify. And if you're not sure, luckily our graphing calculators will tell us it pretty quickly, pretty easily. Okay, come on. Yep. Oh, yeah. Nope. Yep. Okay. Now, the only reason I'm looking at that was, again, this, we can take this as far as we want, and I'll explain that in a minute. Questions on number 5. How do we feel about this here? We feel good with this? Okay. Number 6. The natural log of 5 over 12x. Natural log of 5 over 12x. So again, we start off with what? Quotient, our division. So it's going to be the natural log of our numerator, the top, the whole expression, minus the natural log of the denominator, our whole expression. So we had ln of 5 minus ln of 12x. Yes? Okay. Now, our next part would be product. So we still have ln of 5 minus. Our first one would be ln of 12, ln of x. And there's no powers. We have to have parentheses around this. Because if, I'm going to remove them for a second. As we have this here, and I've kind of mentioned it before, if there's a negative in front of it, it's in the bottom, yes? as this is written, ln of x is plus, yes? Which means, as it's written, that means that x is actually in the top of the fraction, not the bottom, yes? Well, whenever we do the product of something that has that negative in front, you're going to do one of two things. Either A, distribute that negative throughout, or B, put a set of parentheses around it. I think it's easier just to want to put a set of parentheses around that product as you expand, because this is not wrong. This is right. It might not be quote unquote simplified, but it is still the right answer. Here's what we can do is come back and say ln of 5 minus ln of 12 like we had, but then we have minus ln of x. Because both of those will have that negative attached to it, because they're both in the bottom of that fraction. It is the same thing. Now, some of the newer programs that college algebra is using, I really do like, mainly because I've taught the college algebra, is Alex, and it does, especially on the homework, let you check your answers. And it will, unlike Big Ideas, because y'all used it last year, or not last year, possibly last year or 2 years ago, where pretty much the program told you yes or no, right, wrong when you checked. Alex will tell you to simplify, nudge you in the right direction. So most likely if you put that and said it's not fully simplified, okay, then it wants us to distribute that negative. Does that make sense? We good with this here so far? And this here actually is going to, I think, drive home the point I want with the fact that we don't have 3 steps, or I don't use 3 steps with condensing, because most of the ones we condense is not going to be the one with the blue parentheses. It's going to be the last one. So the best way I've found, if we do all 3 steps, is I have to factor that negative out of, regroup all the ones with subtraction, and factor that negative out. So I get back to the blue parentheses. Then we could do the product. This product would normally go first. Or do power and then product and then do quotient. But I've worked through it and thought about it, and there's an easier set of steps that I think works for this. And the first one is our power property. I always start with power property first. I'm going to add this note, take negatives with it. If there's a subtraction, so minus 2 log of 3, minus a number log of 3, or just minus the log, I'm going to treat that like a power. So we always start with the powers. So with our first one here, I'm just going to rewrite it. You don't have to. The first thing we start off with is our power rule, our exponents. Because the 3 is one of our powers. If there's a number out front, we move it back to the exponent. Because our power property stated, and I can write it above, that log base b of m to the n is equal to n times log base b of m. It works both ways. Because if we have n times log base b of m, it means it's the same as log base b of m to the n. Yes? Now our log base, or log of 9, is, well, log of 9. Plus, that 3 is an exponent. We turned it into an exponent to condense, because when we're finished, we want a single logarithm. We want to put it back together so it's 1 log. We're squeezing it all back together. Now this is not going to come into play, it won't ever occur, but the logs have to have the same base for us to do this. So if one of them was log base 2 and the rest are just log, that one gets left out. It has to be the same base. So are we good with this middle one from going from 3 log of 2 to log of 2 cubed? Yes? Okay. Technically, minus log of 3, it's technically negative 1 times log of 3, yes? And when I say take the negative, what I'm saying is take that negative 1 and make it be an exponent. And what that tells us is that this is log of 3 to the negative 1. I think it's easier to deal with negative exponents, and it would be plus, yes. And since we took that negative away, it turns it to plus. I think it's easier to work with negative exponents than it is to try to navigate between, like the last one, trying to reorient with those positive negatives. We take the negative away. Because again, there's 2, unlike the last one that had 3, yes? Do we have any subtraction left? So which one of the 3 are we not going to use anymore? Quotient or division. We don't have subtraction because if 2 things are being subtracted, we can put it as 1 being divided. Quotient's gone. So the only thing we have left is product. And our product was log base b of m times n is equal to log base b of m plus log base b of n. Now we do have 3 things, but there's not too much of a stretch to say that log base b of m in c would be log base b of m plus log base b of n plus log base b of c. Just 2 or more things multiplied together inside turns to addition of the logs. If we have addition of 3 logs with the same base, that means we can put them all together. All these 3 would be log of 9 times 2 to the 3rd times 3 to the negative 1. Even though there's 3 and not 2, it's still, we're multiplying them together. I didn't put them next to each other because they're variables. We could have easily just said 9xy because that's understood to be multiplication. I would be a little hesitant to just do the same thing with this here because they're all just numbers, so it might look like instead of 9 times 2 to the 3rd, it'll look like 92 to the 3rd, so we want to be a little careful there. If it had been 9 times x cubed times z to the negative 1, we could say 9 x to the 3rd z to the negative 1. We don't need the dots. We will need to simplify. So even though we removed the quotient property, we just put it to the end in simplifying. Because if there is a number or variable with a negative exponent, we need to make it positive, especially for this here. And we can do that by moving it from the top of the fraction to the bottom. Okay. 3 on bottom. Now we do need to simplify 2 to the 3rd. Well, the calculator will do that, or 8. Well, we have 9 times 8 over 3, yes? There's 2 things we can do from here, because that simplifies, yes? Because 9 times 8 will, and is 9 times 8 going to be divisible by 3? Well, 9 and 3, yes? And we could go through that division, or 9 times 8 over, so it's log of 24. When we condense, if there's numbers on top and bottom or terms on top and bottom that will simplify, go on and simplify it. Most likely this is going to more likely occur with numbers than it is going to be variables. But That is it with that there. Questions on this here? All right. I'm going to clear some of that up so I have a little more room for the other side. Now again, first step, first part of this here is powers. Log of 6 has positive 1 in front, so it's just going to stay log of 6 plus. We're going to move the 4 up. Telling us this is log of 3 to the 4th. And even though it's a negative, we're going to move it up, making it log of 3 to the negative 1, which makes our sign plus. Go that in. Questions on power? Now we do have product. We have 3 things being added, so it can be rewritten as a single log with what's inside being now realistically at this point I can plug that into a calculator because 6 is our 3 terms, 3 things being multiplied are 6, 3, and 3. Those are all numbers. So really a calculator can do that. It doesn't care that one of them's to the negative 1. But if we take care of that negative property, we have 6 times 3 to the 4th over 3. If that had been anything other than negative 1, we would put it, if it would have been negative 2, it's just over 3 squared. 6 times 3 to the 4th over 3, which is 162. Questions on this here? Not for this one now. I think we have time for at least one more, if not 2. The next one's kind of nice. Because this one here, as we've been doing, well, we use our power property, telling us that it's log of x plus log of 9 to the negative 1. And I will admit this method for doing this one here is not quite as nice, because here we could have done quotient and been done, because it's only 2 things being subtracted. Because the quotient, this 2-step is very nice if we've got a lot of terms and more than one negative. Because now we do have a product telling us that we have log of x times 9 to the negative 1, which is log of x over, which our quotient property would have jumped us straight to it. Questions on this here? Questions on this so far? All right. Last one of condensing that we're going to do here. Power. So yes, it would still be ln of 4 plus 3 to the 3rd, because our power property says we'll take that 3 up with it. And then we'll also take the ln of 12 to the negative 1. We'll take the 3 and negative up with the powers. Now we do have 3 things being added together. So it's the same as ln of 4 times 3 to the third times 12 to the negative 1. 3 to the third. 12. Which would indeed be 4 times 27 over 12, which actually ends up being 9. Because 12 is 3 times 4, yes? So one of the 3's and one of the 4's in top would cancel with 12, leaving us with 3 squared, which is 9. Questions on this here? I'm going to show you this here. The assignment has been posted already. So especially the condense and expand, you can start looking at. We haven't done 3 through 6 yet, but the 13 through 18 we have, so you could start on those. 23 through 26, we have done those. 29 and 30. The only ones we haven't done are the 3, 4, 5, and 6. Huh? I wanted to do the others first because you can actually do the first 4, those 4 problems. It's the same thing. We're applying those properties. But if you notice on the homework, in the instructions, it tells you the value. For log base 3 of 4 and log base 3 of 12, I think is what it is. And we'll do the breaking it apart like we did with the properties, and then substitute those in for the given ones. Yes? Mm-hmm. You all have a good rest of your day. Yes.